After reflection of light, now we shall discuss the refraction of light and the laws of refraction. Now, see the direction of propagation of an obliquely incident ray of light that enters the other medium. Say from one medium to other medium, if this oblique ray is entering, oblique means the slanted ray, then it changes the direction at the interface of the two media. Okay, this phenomenon is nothing but the refraction of light. Okay, if angle of incidence is between 0 to 90, okay, then this ray of light changes its direction of propagation. See here, you can easily understand. You have studied all these things earlier in your 10th standard. This is the incident ray which is falling on this medium. Okay, say for example, this is a glass medium. Okay, and the ray of light is coming from air medium. This is the air medium. Then, if it enters the glass medium, then it goes like this. It does not carry on its original path in this particular direction. It changes its path. It bends. In this phenomena of bending of light at the interface, at this point where the two media are getting separated, this is called the refraction of light. Okay, this you have already studied in your 10th standard. Okay, in this figure, the surface separating the two media is PQ. Here there are different angles which we should understand or which we know already. This is the incident ray which is making an angle with the normal drawn at a point of incidence, that is called angle of incidence. Okay, this point B is an angle of is a point of incidence. At a point of incidence, you draw a perpendicular on a line joining or line separating the two media. Then the angle made by the incident ray with this perpendicular is called the angle of incidence, okay, which is denoted by I. Then this is a refracted ray. Then the refracted ray is making some angle with the perpendicular, okay, that is called angle of refraction. Okay. So here in this particular figure, angle ABN, angle ABN is angle of incidence, and the angle N prime BC, this is called the angle of refraction. Okay. Now see the two laws that the different scientists Snell experimentally obtained, the two laws. Okay, the incident ray, refracted ray, and normal drawn at a point of incidence, at a point which is there on the interface of two media, they lie in the same plane. So these rays which we have understood, okay, which rays we are considering right now? Incident ray, refracted ray, and normal drawn at a point of incidence, they are in the same plane. You can see, okay, they lie in the same plane. Then the ratio of angle of sine of I, okay, ratio of sine of incident angle to the sine of angle of refraction is found to be constant. This ratio is found to be constant, that is ratio of sine of angle of incidence to the sine of angle of refraction is found to be constant. With a different experiment, this is found, which is nothing but the refractive index of medium 2 with respect to medium 1. Okay, so sin I upon sin R is equal to n to 1, that is refractive index of medium 2 with respect to medium 1. It is a constant. Okay, this is the Snell's law, we can say. Okay, n to 1, that is refractive index of medium 2 with respect to medium 1, depends on the wavelength of light, but is independent of the angle of incidence. Okay, so when you change the value of angle of incidence, simultaneously there will be a proportionate change in angle of refraction. So this ratio which you are having, that is constant. Okay, this ratio which you are having is found to be constant. Okay. Now we talk about the optically denser and optically rarer medium. If this ratio, that is n to 1, if this n to 1 is more than 1, n to 1 is found to be more than 1, that is refractive index of 2 is more than 1, then we can say that the refractive index of medium 2 is more than refractive index of medium 1. Then medium 2 is a denser medium and medium 1 is a rarer medium. Okay. So sin I upon sin R, as you have that sin I upon sin R is n to 1, and if this ratio sin I upon sin R is found to be more than 1, then we can say angle of incidence, that is sine of angle of incidence is more than sine of angle of refraction, and therefore I, that is angle of incidence, will be more than the angle of refraction, and the ray which is falling at an interface, okay, after, or rather when it passes through the second medium, then it will bend towards the normal. Okay, so you can see in this figure that this angle of incidence is more than the angle of refraction. So this ray, when it is going from rarer medium to denser medium, what will happen? The angle of refraction is smaller than the angle of incidence, therefore it will bend towards the normal, it bend towards the normal in this medium. Okay. Now opposite, you can understand, if n to 1 is less than 1, then what will happen? Sin I upon sin R will be less than 1. Okay, so we can say I is less than 1. Okay, sin I upon sin R is less than 1, therefore sin I is less than sin R, therefore I less than R. That is, angle of incidence is smaller than the angle of refraction. Now try to understand this part by considering the whole phenomena of refraction. Okay, you can take the glass slab, okay, when the ray of light is incident, then it bends towards the normal. Now when it goes out of this glass slab, then what will happen? It goes away from the normal. So this is the angle of incidence for the second surface, and this becomes the angle of refraction. So what will happen here? I is found to be less than R. Okay, so what happens? The ray of light goes away from the normal when it goes from denser medium. This is a denser medium and air is a rarer medium. So when the ray of light goes from denser medium to rarer medium, then this angle of refraction is found to be more than the angle of incidence, or we can say the ray of light goes away from the normal. Okay. Now there is a meaning, or rather there is a difference between optical density and mass density. Mass density is mass per unit volume. Optical density is the ratio of the speed of light into media. Okay, so that is the main difference. Optical density is different than the mass density. It's a ratio of the speed of light into different media. Okay, it is possible that mass density of optically denser medium may be less. Mass density may be less and its optical density, okay, will be rather more. Or we can say the optically denser medium may be less than that of an optically rarer medium. So try to understand. It is possible that mass density of optically denser medium may be less than that of the optically rarer medium. You have a turpentine oil, okay, which is lighter than water. It floats on the water, okay, but its optical density is higher. Okay, so this is one example of this particular statement, that its optical density is more but its mass density is less. Okay, now we have absolute refractive index whenever the speed of light is compared with the speed of light in vacuum. Say for example, you have this particular medium, say that is glass, and the ray of light is moving from this air or say vacuum, okay, to this glass, and as you know it will bend towards the normal, because vacuum is a optically rarer medium and this glass is optically denser medium. Now the velocity or rather speed of light in vacuum is c, and the speed of light here in this glass medium is v, and this speed is less than this speed in vacuum, and the ratio of c to v, that is speed of light in vacuum to the speed of light in a particular medium, is known as absolute refractive index of the medium. It does not have any unit, so dimensional formula will be m0, l0, t0, and value of refractive index of any medium depends on type of medium, temperature of the medium, and wavelength of light. So these are the three factors: type of medium, temperature, and wavelength of light, on which the refractive index depends. Okay. Now we talk about the relative refractive index. Now see, when you have two different media, say for example you have two different media, and this is say water medium, okay, and this one is a glass medium. Then the ray of light from water medium to glass medium it passes, then the speeds will be different. Let the speed in this particular medium, first medium is v1, the speed of light in second medium is v2. Now if you want to find refractive index of medium 2 with respect to medium 1, then you have to just take the ratio of speed of light in medium 1 to speed of light in medium 2. Okay, now as you know that refractive index is nothing but n2 upon n1, that also we know. Refractive index of 2 upon refractive index of 1, that is giving you a refractive index of medium 2 with respect to medium 1. Thus, these two equations must be same. So n2 upon n1 is equal to v1 upon v2. Okay, so refractive index of 2 with respect to 1 is n2 upon n1, or we can say it is speed of light in first medium to the speed of light in second medium. Okay, now for the two given media, if I1 is the angle of incidence, okay, and r is the refractive index, or rather angle of refraction, then sin I upon sin r is found to be constant, which is called the refractive index. So the ratio of sine of angle of incidence to the sine of angle of refraction is nothing but the refractive index of that medium. Okay, so that is refractive index of medium 2 with respect to medium 1. Okay, now relative refractive index is n to 1. So we can say n to 1 is equal to sin I upon sin r. Okay, so this is very clear. n2 upon n1 is sin I upon sin r, or we can say n2 upon n1, or we can say n1 sin I is equal to n2 sin r. That is again a Snell's law which we have studied. Okay, what happens to it? Okay, this becomes sin I upon sin r is equal to n2 upon n1. So this becomes n1 sin I is equal to n2 sin r. This is a new form of Snell's law. Okay, and as you know that n21 and n12 are inverse of each other. So refractive index of 2 with respect to 1 is the inverse of refractive index of 1 with respect to 2. So now if you multiply these two, n21 and n12, then naturally that is going to give you answer as 1. Okay.